Good day again. I'm Benedict Feliciano and we'll be continuing our discussion on Lecture 1 and we'll be starting to discuss 1.2 Phases of Matter. This will be a very brief one since a lot of the concepts behind this subtopic will be rediscussed in a deeper level in the further lessons. First, as you can see, I made again a diagram where you can see the five most common or the five basic types or phases of matter rather. So as you can see, a solid, a liquid, and a gas, which are considered as baryonic matter. Then we have plasma and Bose-Einstein condensate, which are considered as plasma as the fourth phase of matter and Bose-Einstein condensate as the fifth state of matter. So these arrows with one endpoint and one arrowhead means that there are ways or these states of matter can be can be changed through some types or should I say processes. So when we want to turn solid to liquid, it will be undergoing a process called melting. If a liquid to solid, it will be undergoing freezing, and then so on. I will not be discussing it in a deeper level because we will be using it in another topic, which is thermochemistry. So, phases of matter are commonly referred as some or as to the form of matter which the substance can exist. So there will be differences in the energy levels, how much energy is within that type or substance, its enthalpies, and those differences causes it to have a change in or to have a difference in state of matter. So these differences have or will result rather to differences of properties and which will be having different applications. Properties such as densities, particulate natures, which you can see right now, these are the particulate natures, shapes, volumes, and others will be affected once a change in phase happen. So these are just one common type or example of matter within that state. In a solid, one common one is a rock, or even yourself, your skin, your hair are solids. A liquid is maybe an example is your blood, acetic acid, water, and a lot more. Air that we are breathing, oxygen, hydrogen, nitrogen, are gases. Plasma is the fourth state of matter and is commonly found mostly on outer space on or even in our world in the form of electricity, in lightning and so on. In space we can find it on stars. Lastly, Bose-Einstein condensate. These are mostly laboratory made type of matter, superconductors. What are the differences? A solid, um, it is tightly compact based on its particulate nature. A liquid is somewhat loose, and a gas is very loose, or they do not have a firm structure. A plasma, on the other hand, is also known as a superheated gas. It has gas particles, but not only that the particles or the atoms are loose or having no structure, but also the electrons. they become ionized, and those electrons are deviated from their respective nuclei. As you can see, those positive charged particles are the nuclei consisting of protons and neutrons, and those electrons are not part of those nuclei. But they are one, but they are considered as one type of substance. Lastly, Bose-Einstein condensate is also a gas of bosons that are tightly packed or beginning to form a somewhat weird shape. I mean, it does not have a shape, but it has a definite volume. And one example is a superconductor. So let's see these chips. So this one is a solid because the movement of the particles, it can also, so you can also tell the type of or the state of matter based on its movement of the particulate nature. So as you can see, there is a vibrational movement of solid particles because they are very tightly packed. On the other hand, a liquid has a rotational movement, but they can move in very short distances. On the gas side, there are very react somewhat there's a lot of collision happening within those particles. Next is these two states of matter. So this one, as you can see, those red particles that you can see within this chip are the nuclei of the gases. The blue ones are the electrons of those gases. So as you can see, they are not in a structured form, neither those electrons. They are very loose and highly and they are moving in a very fast in very fast velocities. So in a Bose-Einstein condensate, it actually happens when its temperature almost reaches um, the absolute zero, which is 0 Kelvin. But according to the laws of thermodynamics, it is very impossible to reach that kind of temperature. So, as you can see, it is in nanokelvins. Nanokelvin, so it is not really 0 Kelvin, but it is somewhat 2 times 10 raised to negative 9 Kelvin or so. So this is 200, and it can also go down to 40 nanokelvins. So that ends the second part of our lecture 1, and you may now proceed to the third lecture.